This video is to demonstrate applications that we can actually use with quadratic functions. So something you need to be aware of, you need to understand that the letter t represents time. As a quick review at the top, the coefficient in front of t refers to initial velocity in which something is being thrown or launched, and the constant at the end is your height above or below ground level. This function does represent the height or distance you are above ground level. The first derivative will represent instantaneous velocity. So as we go through some applications, I'm going to keep referring back to these things. Now I'm just trying to show you my notes that go along with this. I'll try to explain it. Then I do have all the numbers and calculations there for you to review at your own time. Okay, so starting off with this example, my original function f of t should equal a negative 16 t squared plus 145t. I don't have a constant at the end because I'm starting on ground level. My first derivative is shown there. First question that goes with it is find the maximum height. If you recall when we looked at critical points, maximum and minimum points came from using the first derivative. So it's very similar with this. So you would want to take the first derivative, set it equal to 0, and solve for the variable t. That's going to give you the amount of time. As long as you have time, you can substitute it into the original function, which is the height. The next question wants to know how long in total will the rocket be in the air. This is actually referring to, if we think about this being launched upwards, it's making a parabola. It's going up and coming back down. We want to know what the time is once it reaches the end. Something that we know about that is we started on the ground, it's going to land on the ground. So that's why we're going to take our height function and set it equal to 0. We want to try to obtain when it comes back to the ground. Finding the instantaneous velocity when it hits the ground. In the physics world, they will tell you that it equals 0. Doing the calculations, we want to know that split second right as it goes to hit the ground. So we're going to use the time from the question above, and we would substitute it into the first derivative because that's instantaneous velocity. Okay, my next question. What's the instantaneous velocity at maximum height? That is always 0 feet per second. An object will automatically stop as soon as it reaches its maximum point, then it will gain speed again as it comes downwards. Next question about the instantaneous velocity at 2.5 seconds. Keep in mind what I mentioned about knowing what does t represent, what's f of t represent, and what's the first derivative represent. You're given a time, 2.5 seconds, so you're told what letter t is. All you need to do is use the instantaneous velocity and substitute that number in place of the t. The last question is very similar to that one. My next example, I want to know about the time when a velocity is 80 feet per second. Since 80 represents my velocity, I want to use the first derivative and I'm going to set it equal to 80. I would not want to substitute 80 in for the letter t because 80 is not a time. I would really advise that you look at units and measure. That's helpful in determining what information you do have and what you're working with. So then the question below at 1.5 seconds, that's a t, that's time. The question wants you to find height, so you would use the original f of t function and replace every letter t in it with 1.5. Okay, my next question, what is the velocity of the rocket when it is 50 feet in the air after it is launched? 50 feet is a height or a distance. So I'm going to be using the original function. I would set it equal to 50 and solve for t. That would not answer my question. At this point, you only found what time is. You would have to continue the next step and put it back into the velocity function to see what the actual velocity is. The last question on this slide, what is the velocity when it is 20 feet in the air just before hitting the ground? That one's similar to above. What is the height of the rocket when it has a velocity of 30 feet per second? Once again, I'm going to look at my unit of measure. That's an instantaneous velocity. So I would set my first derivative equal to that value of 30, solve for t, and then in order to answer the question wants to know a height, so I would have to continue on and substitute t in the original height equation. My next question, how long will it take the rocket to hit the ground if it is 100 feet from the ground? So 100 feet is a distance. This one's a two-part problem. You need to find the time whenever it's 100 feet from the ground. You need to find the time when it's going to land on the ground, and then you would subtract between those two values. Now I have the same questions with all the math here for you to go ahead and take a look at. You can replay the video as needed, but most of the calculations you should be able to solve. I do want to point out a few things with some of these. Please make sure you always put units of measure with your answer. When I get to this second question, about how long in total will the rocket be in the air, when I solve that, that's a quadratic function, which means I'm going to get two answers. My final answer to this would be 9.06 seconds. The reason I'm getting two answers is you need to remember this is forming a parabola. So my beginning, 0 seconds, is when I start. My ending is the one that I'm actually looking for in this question. So it is reasonable I should have two times. And for each of these heights, we're going to look at things. There should be when you have two times for the same height. The only time you don't is at the maximum point. There's only going to be one time there. Okay, my last question on this slide about finding the instantaneous velocity. If we solve this, I'm going to get this value, negative 144.92 feet per second. A velocity isn't negative, so what I need to include in here is mathematically I should put absolute values around this. The negative is only indicating direction. So that makes sense. As something's coming down in a parabola, it should have a negative velocity just indicating that it's going down. So technically in my answer I should make that the absolute value. Okay, once again, the last question on here, talking about instantaneous velocity, I had gotten a negative value, so I need to go back and make that the absolute value of negative 143. The negative is only indicating that it's coming down and not going up. I think these two are pretty self-explanatory for you to look at. My first question on this slide about the velocity when it's 50 feet in the air after it's launched. Because I'm solving a quadratic equation, once again I'm going to get two answers. So now I need to decide which of these two answers is the best. So if I go back and look within the question, when it is 50 feet in the air after it's launched. So remember that we start and our parabola ends. So I want when we're going up. That's going to be the least amount of time. So at 0.3 seconds, it's going to be at 50 feet. In its descent coming back down, or 8.7 seconds later, it's going to be at 50 feet again. But the question wants to know after it's launched, so that's going to be the less time out of the two. And then in the last question, once again, I'm going to get 2 times. This one indicates about 20 feet just before hitting the ground. That means I want the 8.92 seconds. The 0.14 seconds would be right after it was launched, not as it's coming down. And then to finish this one, I would substitute in. Once again, I get a negative velocity, so I need to put an absolute value with that. And for the last of our examples, I think these ones are pretty much self-explanatory. The very last question, off to the side here, I do have an indication that along the lines, we did find that value earlier to be 9.06 seconds, so we don't have to go through all those calculations again. But you do need to find the amount of time that it takes whenever it's 100 feet. Keywords in this one, 100 feet from the ground on its descent, so that means I would want this time and not the first time. So please review these examples as needed. Let me know if you have any questions.